Hello everyone, and welcome to this course on BSP 303, that is Digital Systems and Applications. So this is basically designed for BSc third semester students of University of Science and Technology, Meghalaya. However, this course may also be useful for other undergraduate programs like BSc in Electronics and also BTech in Electronics Engineering. So basically in this course, let me first speak about the course content. So in this course, basically we are going to study about different kind of, the logic gates, which is the building block of digital electronics, and then we will be studying about different kind of combinational circuits and sequential circuits, all in detail. Before we begin, we will have to start our discussion with the number systems. There are several types of number systems, and which are, very important in digital electronics, especially the binary number systems. So that is what we are going to study initially. We are going to study about the different number systems, which include the binary number system, the decimal number system, the octal number system, and the hexadecimal number systems. We'll also see how we can do the number conversion first. I will tell you the significance that why we are studying these number systems later on when we start the lecture. Then after completing these number systems, we will be studying about the logic gate and the Boolean algebra which is involved in this logic gate, and how we can simplify a complex Boolean expression using different kind of Boolean laws and applying the Boolean algebra. Then after that, we will be studying in detail about the combinational circuits and the sequential circuits, which are the two common different type of circuits in digital electronics. So let us begin our discussion, and we will first start with our discussion on the number systems, the different type of number systems which are used in digital electronics. So I'm just sharing the screen. Okay, so here we can see the title of the course and the course code. Of course, this course code is for University of Science and Technology, Meghalaya. We call this course code as BSP 303. This is the course code. What do we call here? Okay, so all right, this is the course code, and this is, as I informed you earlier, that this is a course which is designed for University of Science and Technology for the students of UST. So let us begin our discussion, and let us go to the first lecture of this course. That is, okay, first we are going to see the basic introduction of digital circuits and number systems. Okay, so before we actually go and discuss the digital circuits, let us try and understand what is the difference between the analog circuits and digital circuits, or what is the difference between the continuous time signal and the discrete time signal. Then only we will go to the number systems. All right, so let us see what is this difference between the analog circuits and the digital circuits. So I'm just going to write here let me just try to note it down here. So this side I'm writing the analog circuits. All right, and this side let me write down the digital circuits. I'm just writing in short circuit. Okay. So let us try and understand what is the difference between these analog circuits and digital circuits. Now, let me try to make it very brief here. I am just starting with an example. An example of analog circuits. So let me write the example here, amplifier. Okay. An amplifier, a transistor amplifier, let us take for simplicity, a transistor amplifier is a very simple example of an analog circuit. Why? Because the signal which is fed to this amplifier is a continuous time signal. So those circuits which can analyze or which can process the continuous time signals are known as the analog circuits. And those circuits which can process the discrete time signals are known as the digital circuits. We'll come back to that one. So any circuits which can process the continuous time signal is known as analog circuits. Now, what is a continuous time signal? Let me just try to draw the signal here. Suppose we have such kind of signals, time t, and let me say this side is the amplitude of the signal. I'm just writing this as A. Okay. So now you see that why this signal is, I'm just writing in short here, this is continuous time signal. So I'm just writing it CTS. So within a specific range, let us say this is a signal from 0 to 5 volt plus 5 volt and then minus 5 volt. So between this range, plus 5 volt to minus 5 volt, or you can say that from 0 to plus 5 volt, within this range, these type of signal can have any values. For example, 0, it can have 0, or it can have 0.1, 0.2, 0.3, 0.4, 0.568, or 1.725, and so on. So within a specific range, this 0 to 5 volt, it can have any values in this range. So that is why this kind of signal is known as the continuous time signal. Okay, and the circuits which can process such kind of signal are known as analog circuits. Okay, so now let us come back to the the digital circuits. Okay, so for example, let me write down here the digital calculator. This is an example of a digital circuits. Now, the circuits which can process discrete time signals are known as. This is a very simple example. Later on, we'll try to see some more examples for these digital circuits. So now, the circuits which can process the discrete time signal is known as the. So here, let me just try to use a different color. So now, what is a discrete time signal? I'm just drawing the discrete time signal here. The signal of such kind of characteristics is known as a discrete time signal. So let me call this side as the time axis, and this is the amplitude axis. Okay. So again, let me say this is the 0 volt level, and this is the 5 volt level. All right. So now you see that this kind of signal, I will call this as DTS, discrete time signal. Now the word discrete itself says that the values are not continuous. For example, at this particular instant, the value of this signal is 0. Okay. Now, and then if you move further towards the time axis, what happens? The values goes from 0 to 5 volt immediately. Okay. So, and then if you move further towards the x-axis, you can notice that the values are either at plus 5 volt or 0 volt, plus 5 volt or 0. Okay. So within this specific range from 0 to 5 volt, within this specific range, the discrete time signal is having only two values, that is 0, either 0 volt or 5. Okay. And such kind of signals are known as discrete time signals, and the circuits which process this kind of signals is known as digital circuits. So I hope this section is clear. So let me now move on to the next one. Let me just slide this down. Okay, and let us move forward. Now, you know that in digital electronics, various number systems are used. Now, let me tell you the significance of this number system first. Okay, number systems. number systems are used in digital circuits. Now, in digital electronics, the number system is actually used to store the information. Okay, these number system are actually used to store the information. That is why we are using these number systems. And the number systems, so these number systems, they have actually different bases. Okay? They have different bases. Okay, this number system, they have different bases, and some of the most commonly used number systems are, let me just put it down here. So some of the commonly used number system are binary number systems. Okay, then you have octal number system, then you have decimal number system, then you have hexadecimal. I'm just writing in short. Then we have these hexadecimal number systems. Now, as I mentioned, that they are used to store the information in digital electronics, and this is the significance of the number system. So that is why, I mean, we need to study about the number system first and foremost when we begin any course in digital electronics. Okay, so whenever, suppose, let me put it the other way like that, whenever we type some letters or words in a computer, then the data is processed by the computer in the form of only zeros and ones. Okay, whenever we type anything in it is processed by the computer only in the form of these zeros and ones. Okay, and a computer can understand positional number systems, and binary number systems is also a positional number system. It can understand a positional number systems where the position of each, I mean, each bit will tell you, I mean, the symbols which are the symbols, all the symbols will have different weightage assigned to them, and according to the weight assigned to those numbers, the information are stored. Okay, so we will see in detail about this number system. So this is the significance of the number system. So now let us move further and let us study about this number system first. Okay? Then we'll go to the logic gates. So now the number systems. Okay, any number systems, let me write it from here. Any number system, let me say whether it is decimal, hexadecimal, octal. I'm trying to write the general, I mean, representation of a number system. Okay, any number system n, and this b represents the base of this number system. I'll tell you about it. Can be written in this way. So d n minus 1, and we have d n minus 2. We have di, d1, d0. Then we have a radix point. This is the decimal point which we call in our normal number system. So here we call this as the radix point. And then similarly, we have the fractional part, that is d minus 1, d minus 2, and we have d minus f. Similarly, it may go up to the minus n. Okay. So here you can see that I have written the number system in a very general way. So now let me try to, I mean, divide this. So you see, this is the integer part of the number system. Okay, these are the from the radix point on the left side, we call that these are the integer part, and then these are the fractional part. Okay, so here let me just write integers, and then these are the fractions. Okay, all right. And then now here you see these integers and the fractions, they are separated by a point, and in digital electronics we call this point as the radix point. Okay? We call this point as the radix point. All right. So these are the I mean the basic information about the number system. So here let me try to tell you the significance of, I mean, each term here, what does this term represents. All right, so the first one here, this n, actually this is the number. whatever number we are writing, capital N, this is the number, okay, and the B here represents the base. B here represents the base, okay. And you see here dn minus 1, this one, dn minus 1. dn minus 1, we will call here this as the most significant digit. So I am writing this in short. This is the MSD, the most significant digit, okay. And the leftmost side, which is this one, okay, the leftmost side, that is D minus M, this is known as the LSD, okay. This is the least significant digit. And here, what are these M and N now? The N represents the number of digits in the integer portion, okay. N represents the number of digit in the integer portion, and the M represents the number of digit in the fractional portion, okay. Fine. So in general, we can write this any number system in this general. This is the general representation of any kind of number system, okay. So before, okay, today, so let us go and see one by one what are the characteristics of different number system, okay. Let me just slide it down and then, okay. So we'll begin with the first one, the characteristics of the binary number system, okay. So this is the first one, this is binary number system. Binary number system. All right. So let me tell you the characteristics of this one first. Now, the base of a binary number system, let me just put it B here. The base of the binary number system is 2. Okay. So why the base is 2? It will be clear to you now. The base, which is the B, and the symbols used. So what are the symbols used? And these symbols used are actually, if we see the general expression, these are nothing but either integer, or you can say the fractional digit. Okay, these are represented by di and d minus f. So the symbol used are actually 0 and 1. Okay, only two symbols are used in binary number system, 0 and 1. And the next one, that is the weight assigned. Now, how the weights are assigned? How the weights are assigned to this number system? The weight are assigned in terms of 2 raised to the power I for integer, or 2 raised to the power minus f for fractional. This is how the weight are assigned. Okay, and this will tell you, as per the weight assigned to a specific digit, will tell you that whether that digit is having the most significant, whether that is the most significant digit or the least significant digit. I mean, by calculating the weight assigned, you can know the position of that particular digit. For example, let me just try to write down an example of a binary number system, and at the same time, I'm going to try to write down the weight assigned. Let me try to make it very simple. Suppose I have a number 101.11. Okay. Now this is our number system, which is in binary number system. Now the weight, this is the radix point. Now the weight assigned to this digit could be 2 raised to the power 0. Okay, and this 0 would be, the weight assigned to this 0 is 2 raised to the power 1. Similarly, the weight assigned to this 1, it is 2 raised to the power 2. Okay. Now, after the decimal point, you have this general expression, that is 2 raised to the power minus f. So the weight assigned to this 1, it would be nothing but 2 raised to the power minus f. This is 2 raised to the power minus 1. And then the weight assigned to this one is 2 raised to the power minus 2. Okay. So this is how the weight assigned is calculated in a binary number system. Okay. So let me go to the next one. That is the decimal. So the second one, I am just writing this as decimal number system. Okay. So let me write down the base of decimal number system. The base of decimal number system is 10. And what are the symbols used? What are the symbols used? This is the value of di or d minus f. Okay. Symbols used, it will start from 0, 1, then 2, 3, 4, 5, 6, 7, 8, and 9. Okay. From 0 till 9. So these 10 symbols are used. That is why the base is represented as 10. Now, how is the weight? Calculated for particular digit. The weight is calculated with respect of 10 raised to the power I or 10 raised to the power minus f. Okay. In this way, the weight assigned is calculated for decimal. You can take one particular example of this number system. Now, example, let me just write down the example of this number system. For example, 349.25. So this is an example of a decimal number system. And basically, these are enclosed within the bracket, and then it is represented by this base 10. So whenever this number system is represented by base 10, then this is decimal number system. So let us move forward to the octal, the next one, that is the octal. Okay. So the third one, we have octal number system. Now the base for octal number system is 8, and let me write down the symbols. It will start from 0, 1, 2, 3, 4, 5, 6, 7. Okay. From 0 till 7. So this is these are the different symbols which are used. 8 symbols are assigned. Okay. And then now the weight, you can calculate the weight of such kind of number system by, 8 raised to the power either integer or 8 raised to the power minus f. That is the fractional part. Okay. You can take one particular example and then calculate the weight assigned. For example, let me write down any number. Okay. Suppose I write down this number 958.25. Now, this is an octal number system. No, this is not an octal number system. Why? Because you see that 9 is here. So I cannot take this example as the octal number system. In fact, this example would be a decimal number system rather, because the symbol for the octal number system is 0 till 7. Okay, so that is why I need to write down another example, 567.25. Now here you see, so this number system is octal number system. Okay, now see, to differentiate whether this is octal or decimal, same number system can be decimal as well. So that is why they are any number system in digital electronics. Whenever we write any number system, then we write it as the base. Okay, from that base only we will be able to differentiate whether this is an octal number system or decimal. So it may be a decimal number system also, but in this particular case I'm taking this as the octal, so I'm writing the base as 8, not 10. Okay, so this is an example, and the weight assigned to each digit, as I mentioned you. For example, if you want to calculate the weight assigned to 7, then you need to calculate it like 8 raised to the power 0. Okay, and the weight assigned to this one, it would be 8 raised to the power 1. Similarly, for this one, it is 8 raised to the power 2, and on the fractional side, 8 raised to the power minus 1 and minus 2. Okay, this is how the weight assigned are calculated. Fine. So one more number system, let us see. That is the hexadecimal number system. The fourth one, which we are going to talk about, this is the hexadecimal number system. Hexadecimal number system. Okay, now the base of this number system is 16. Now, if I have to write down the symbols, it will be from 0 to 9. So there are 10 symbols from 0 to 9, as in the case of your decimal. And then some characters are also there, like A, B, C, D, E, and F. 6 characters. Okay, from 0, 1, 2, 3 up to 9, and then you have A, B, C, D, E, and F. So this is these are the symbols which are used in hexadecimal number systems. And the weight assigned, it's quite simple now. The weight assigned to each digit is calculated by 16 raised to the power I for integer part and 16 raised to the power minus F for the fractional part. You can calculate the respective weight assigned to each symbol. Okay, so any example we can give? Yeah, we can think of many examples, like for example 3F A9 A9.56. Okay, so this is a hexadecimal number system because with the numbers, some characters are also included here. So this is how you are. This is the very brief introduction about the number system. So today we will just stop the lecture here. We will see in the next lecture like the detail of all the number systems, like the binary number systems, the decimal, the octal, and more importantly, in the next lecture, we will be talking about the, in the next lecture, we'll be talking about the, the conversion of this number system, how we can convert the number system from one to another. Okay, so with this, I would like to conclude today's session. So in the next session, as I mentioned, that we will be talking about the conversion of the number system. So thank you everyone, and see you all in the next lecture.